Hi everyone, welcome to another experiment in your physical science experience. In this experiment, we will investigate how the period of a simple pendulum varies with the length of the pendulum, the mass of the bob, and the magnitude of the bob's displacement from the equilibrium position. This experiment is divided into 3 procedures. In procedure 1, we will determine the period of a simple pendulum of various length. In procedure 2, we will determine the period of a simple pendulum for different masses. In procedure 3, we will determine the period of a simple pendulum for various displacements for the pendulum's bob. So let us begin procedure 1. So here we have a setup of a simple pendulum. The cord is going to represent the length of the pendulum, and we'll use varying lengths in procedure 1. And here the mass that is attached to the string or to the length of the pendulum is known as the bob. So first we're going to take the mass of the bob. And the mass of the bob is 72.87. So I'll go ahead and record the mass of the bob as 72.87. So the mass of the bob is 72.87. And that's of course in grams. Then I'm going to go ahead and I'm going to measure the length of the pendulum. In procedure 1, we're going to vary the length of the pendulum. Now, the first length that we'll be using is 120 centimeters, and the second length will be 60 centimeters, the third will be 30, and the fourth will be 15 centimeters. So we are going to begin the experiment with the longest length, which is 120 centimeters. Now, the length of the pendulum is from this position to this location here. And right now the pendulum is in its equilibrium position. As the pendulum swings to this side, it now is in a non-equilibrium position. Then it comes back here and it swings to this side to a non-equilibrium position. Now, for the length of 120 centimeters, I'm going to displace the pendulum from its equilibrium position by an arc length, which is 1/12 of the length, so that's 12. So I'm going to displace it 12 centimeters. And then when it swings from this non-equilibrium position, and it goes over there and back, that's known as 1 cycle. So let us begin the experiment. All right, so here I'll do the displacement one more time because I messed that up. So here it's at its equilibrium position, and I will just move I'll displace the bob by 12 centimeters, and now I am ready to begin. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, how long did it take?
23 seconds.
Okay, so 23 seconds. So the length of the pendulum that I started with at first was 120 centimeters, and the time it took for trial 1 was 23 seconds. So 23 seconds.
No, 23.68 seconds actually.
Okay, a correction here. So it was 23.68 seconds. Now I have to do 2 more trials at this length. So I'm going to go ahead and make the displacement once again. So I've displaced it to 12 centimeter. One, 2, 3, 4, 5, 6, 7, 8, 9, 10.
23.91.
Okay, so we have 1 trial left at this length. So again, I will displace the pendulum by 12 centimeters. Okay, so we're repeating the 3rd trial. It seems to be a little off, so I'm going to go ahead and displace my pendulum from the equilibrium position 12 centimeters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
23.66.
So for the third trial, we have 23.66 seconds. All right, so now we need to take the average time for the 3 trials. So we have So we have 23.68 plus 23.91 plus 23.66. And when we add these, we have So we have 71.20, and we're going to divide this by 3, and here we have 23.73 seconds. Now the time that it takes for 1 cycle is the average time for 3 trials divided by 10. So here we will have 2.373 seconds. And then we will go ahead. I'm going to leave you to do this column on your own. So all you're doing is squaring the time it takes for a period. So you're going to be squaring 2.373 seconds. So you're going to square that and you will put the value in. All right, so now it's time to go to our second length of pendulum, which is going to be 60 centimeters. So I'll go ahead and double check to make sure that this is 60 centimeters. So right here we have 60. So we're going to change the length of the pendulum, and I'll double check the length to make sure I have 60. So now I need to displace the pendulum from its equilibrium position 1/10 of the length. The length is 60, so 1/10 of 60 is 6. So right now I'm going to displace it 6 centimeters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
17.64.
Okay, so it's 17.
64.
Okay, so at 60 centimeters, the time for 10 cycles is 17.61. 64. Okay, so now I need to repeat this 2 more times. So I'm gonna go ahead and displace my bob 6 centimeters from the equilibrium position. Do the 3rd trial, and then we might have to repeat the 1st one. Again, I'm going to go ahead and displace the bob 6 centimeters from the equilibrium position. So here's my equilibrium position. So I'm displacing the bob 6 centimeters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
17.4.
17.40. Now it seems like I need to do one more trial to determine
No.
if it's 16.
17.04.
Oh, 17.04. But I still need to do another trial to see if this is 16 point something or 17 point something. So one last trial. All right, so here I have the bob at the equilibrium position. I'm going to move it 6 centimeters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
17 seconds exactly.
17 seconds. All right. So I'm going to change the 2nd trial to 17 seconds. All right, so now I'm going to average these like I did before. So I have 17 seconds, 17.04 seconds, and 17.64 seconds. All right, so here I have 51.68, and when I divide this by 3, I will have 17 point, and then this is 17.23. So the average here is 17.23 seconds. And then when I divide it by 10, because this is 10 cycles, so if I need the time for 1 cycle period, that would be 17.23 divided by 10, which is 1.723 seconds. And then here, I am going to go ahead and square 1.723. All right, now we go on to the third length, and that's going to be 30 centimeters. So the third length is 30 centimeters. All right, so I'm going to find the length that corresponds to 30 centimeters. I'm going to displace the pendulum bob 3 centimeters because 1/10 of 30 is 3. Let me do that again. So here we have the pendulum in its equilibrium position, and I'll go ahead and I'll displace it to 3 centimeters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
11.25.
Okay, 11.25. All right, now I need to do 2 more trials. Again, I have the pendulum in its equilibrium position, and I will displace it 3 centimeters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
11.13.
Okay. 11.13. All right, so one more trial left in this on this length of pendulum. So here again, here is my equilibrium position, and I'm going to displace it by 3 centimeters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
11.27.
11.27. Now I did the first 2 examples for you, so I'm going to leave you the last 2 where you will do the average time it takes for each trial, the time for 1 cycle period, and then you will do the period squared. So I'm going to leave you to do that part for yourself. All right, so now we are on the final length of pendulum, and the final length of pendulum is 15 centimeters. So I'm going to go ahead and make sure that we have a length that is 15. So here I'm measuring, and right here is 15. So I'm going to tie my cord so that I have the length 15 centimeters. Alright, so now I am going to displace this 1.5 centimeters. So here I've displaced, so here's my equilibrium position, and I'm displacing it 1.5 centimeters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
8.52.
All right, so at 15 centimeter, when the length of the pendulum is 15 centimeter, it's 8.17 seconds. All right, so we have 2 more trials to do. so now I'm going to go ahead and do the displacement from the equilibrium position again. So it's 1.5 centimeters from the equilibrium position. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
8.33.
All right, so that was 8.33. All right, the final one, so I'm going to bring it back to the equilibrium position. And then I will displace it 1.5 centimeters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
8.42.
So this is 8.42. Again, I'm going to go ahead and I'm going to ask you to do the averaging. So this is our procedure 1. This is the data for procedure 1. And I showed you how to complete the information for the first two data set, and you will complete it for the other 2 data set. So in procedure 2, we're going to change the mass of the pendulum, or we're going to use a pendulum bob that has a different mass. So I'll go ahead and put this mass on the balance, and then we will record the mass of the second pendulum bob. So the mass of the second pendulum bob is 23.96. 23.96 grams. And then we're going to basically repeat the experiment that we did previously. So I'm going to go ahead and start with my longest length, and that is 120. And then I'm going to displace this 12, so I'm going to displace it 12 centimeters from the equilibrium position. So here we are, 12 centimeters from the equilibrium position. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
21.51.
Okay. So 21.51 is our first trial, 21.51 seconds. All right, so again, we're going to be at the equilibrium position, and we're going to displace the bob 12 centimeters. One, 2, 3, 4, 5, 6, 7, 8, 9, 10.
21.40.
All right, so we have our final trial. So again, we're going to put the bob at the equilibrium position, and then I'm going to displace it 12 centimeters. One, 2, 3, 4, 5, 6, 7, 8, 9, 10.
21.36.
Okay, so 21.36. All right, so now you're going to add these three numbers, divide by 3 to get the average time for 3 trials. And like in the first procedure, we're going to divide that number by 10 to get the time for 1 cycle period, and then we're going to square that number. All right, so now I need to go to the second length, and I'll be reminding you that the second length is 60 centimeters. So I'm going to double check my measurement. I need 60 centimeters. All right, so this is 60 centimeters. Now I'm going to displace the bob 6 centimeters from the equilibrium position. One, 2, 3, 4, 5, 6, 7, 8, 9, 10.
15.44.
So 15.44 seconds. All right, so we have 2 trials left to do here. So we have 2 trials. So I'm displacing it 6 centimeters again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
15.62.
Okay, 15.62. All right, so now we have our final trial at this length. So I'm going to displace it 6 centimeters to make sure that this is our equilibrium position, and I'm displacing it 6 centimeters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
15.04.
Okay. So 15.04. All right, so now we move to 30 centimeters. So now, at the 30 centimeter mark, we're going to displace the pendulum from the equilibrium position by 3 centimeters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
11.31.
Alright, so I'm going to do the same thing again, 3 centimeters from the equilibrium position. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
11.73.
11.73. Right. The final trial. So here we are at the equilibrium position, and I'm displacing it 3 centimeters. One, 2, 3, 4, 5, 6, 7, 8, 9, 10.
11.20.
All right, so we have the final trial to do, and that is at 15 centimeters. All right, so at this point, I'll be displacing the pendulum by 1.5 centimeters. Let me do that again. So I'm displacing the pendulum from its equilibrium position by 1.5 centimeters. One, 2, 3, 4, 5, 6, 7, 8, 9, 10.
8.19.
Again, 1.5 from the equilibrium position. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
8.17.
Okay, so again, I'll displace this 1.5 centimeters from the equilibrium position. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
8.19 again?
8.19. All right, so we're done with procedure 2, and in procedure 3, we will be determining the period of a simple pendulum for various displacement of pendulums. So in this experiment, we're going to use the same length pendulum, which is 120 centimeters, and then we're going to do the arc length of 12, 24, 36, and 48. So first, I'm going to display the pendulum. 12. And first of all, we did this the first time when we. So I'm going to skip the first arc length because we already did that in procedure 1, and we'll go to the arc length of 24. So we're going to fill out from the arc length of 24. So here is 24. So here is our equilibrium position. Here is our equilibrium position right here. And then I'm going to displace this 24. So that's 24. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
21.89.
again, I'm going to do 2 more trials. One, 2, 3, 4, 5, 6, 7, 8, 9, 10.
2106.
One, 2, 3, 4, 5, 6, 7, 8, 9, 10.
21.11.
All right, so now we are going to displace the arc length to 36 centimeters. So here's my equilibrium position. And I'll displace it to 36 centimeters. One, 2, 3, 4, 5, 6, 7, 8, 9, 10.
21.74.
All right. I'll do that again. I'm going to displace the arc 36 centimeters. One, 2, 3, 4, 5, 6, 7, 8, 9, 10.
21.14.
One, 2, 3, 4, 5, 6, 7, 8, 9, 10.
21.37.
21.37. All right, so we have one final thing to do. All right, so now we're going to displace. Yeah.
Okay. Good.
1, 2, 3, 4, 10.
21.28.
I think something in the last one is something went wrong.
Hmm.
One, two, three, 4, 5, 6, 7, 8, 9, 10.
21.87.
The arc length 48 centimeters. So I'll displace, let me go back to the equilibrium position, and I will displace it to 48. So here's the equilibrium position. Oh, child. So this is the equilibrium position, and I'll displace it to 48. One, two, three, 4, 5, 6, 7, 8, 9, 10.
21.52.
All right. So now we've come to the end of another experiment, and I want to thank you for watching. I will see you in class this week. So you can ask me any questions via email if you have questions.